Hello, algebra class, and welcome to this video explaining where the quadratic formula comes from and then using it. So we're going to actually derive the quadratic formula and see where this crazy negative b over 2a with the square root thing actually comes from. The way we're going to do that is by solving this equation. Now you might ask, how in the world could you possibly solve this equation without the quadratic formula? Well, it doesn't factor. We certainly don't know what a, b, and c are and what the GCF is or anything, so we can't solve this by factoring. So the only thing we can do to try to solve this quadratic formula or quadratic equation is complete the square. How are we going to do that? Well, let's remember your training. So what I'm going to do is I'm going to start by subtracting c from both sides, and I get ax squared plus bx is equal to negative c. Now, the next thing I'm going to do, if you remember, and I know it's a while ago, if you remember, we wanted to get rid of this leading coefficient. So I'm going to divide everything by a. Everybody gets divided by a. And so I have x squared plus b over ax is equal to negative c over a. Okay. Please never lose sight of what we're doing. We're solving for x. We are trying to get x by itself, okay? Throughout all of this, everything I'm doing is to try to come up with a way to solve for x. So when we're done, we're going to be left with x equals, and then hopefully what looks like the quadratic formula on the other side. So always keep that in mind. We are solving for x. All right. Now, the way we're doing it, as I said, is we're completing the square. So this whole side has to turn into x plus something squared. And what is that something? Well, remember, we take this linear coefficient and we divide it in half, which means we're going to double the denominator and get b over 2a. Which means in order to complete the square, we have to add back b over 2a squared, which is, I'll just write it b over 2a squared here. And when I write it on the other side, I'll actually figure out what that is. That's b squared over 2a squared. It's 2a times 2a, which is 4a squared. Okay. On the left side, I have successfully completed the square. On the right side, I have two fractions that I'm adding together. And if I'm adding fractions, back in 6th grade, you learned when you add fractions, you need a common denominator. And my common denominator is not a, it's 4a squared. So the plus b squared, that's okay. The negative c, that needs to be changed. So think about what I need to multiply top and bottom by to turn a into 4a squared. I need to multiply top and bottom by 4a. 4a times a negative c is minus 4ac. And maybe this is starting to look a little bit like you kind of see what's going on here. Maybe what would help is if instead of writing negative 4ac plus b squared, I switched the order. And instead I wrote b squared minus 4ac. And some of you might be thinking, hey, I know that. That's the discriminant. And others of you are thinking something completely different because you're not watching this video. Okay, now what I'm going to do, remember, don't take your eye off the prize. We're solving for x. I'm going to square root both sides. And so on the left side, I have x plus b over 2a is equal to, I'm taking a square root, so I have to account for the fact that there are two answers, plus or minus b squared minus 4ac all over 4a squared. Okay, the numerator can't be changed. I can't take a square root of a b squared and a square root of a 4ac because square roots don't distribute over subtraction. If we were in school, this probably would have been the 8,000th time I would have said square roots don't distribute over addition or subtraction. But we're not in school, so it's probably only like the 4,000th time. Maybe it's only the second time you remember, though. Maybe it's the first time you're actually hearing it. Who knows? But the denominator, I can take the square root. Okay, so maybe instead of taking the square root of the whole thing, what might make more sense is taking the square root of the top, b squared minus 4ac, over the square root of the bottom, 4a squared. And of course, that is still equal to x plus 2a. All right, so x plus b over 2a is equal to that numerator, the square root of the discriminant. And what is the square root of 4a squared? Well, the square root of 4 is 2, and the square root of a squared is a, so it's all over 2a. That sounds familiar too. Now, the last thing I'm going to do is I am going to subtract b over 2a, because remember, I'm solving for x. So minus b over 2a minus b over 2a, and I am left with x is equal to, we'll just put this thing right out in front. Oh, I forgot. That's a plus or minus. We're going to put that thing right out in front. Negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And just as I said before, here we are adding and subtracting at the same time fractions. So we need a common denominator. But guess what? We have a common denominator. This is great news. I don't have to change anything. I can keep everything over 2a, and I get negative b plus or minus the square root of the discriminant, b squared minus 4ac. So I can see that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you can go back and listen to me singing that as often as you want. You can just loop it if you'd like. All right, let's use our quadratic formula 2 times. For the first problem, I have 6x squared plus 7x minus 11 is equal to 0. I can try to factor this, but if I try to split the middle term, I get negative 66, which is, let's see, 11 and 6, 22 and 3, 33 and 2. Nothing I can get to make 7. So there's nothing I can do to factor this. This is not factorable. I could either complete the square, which is going to be messy if I have to divide everything by 6, and my middle term is 7 over 6. It looks like it's a last resort, but it looks like my best bet is to use the quadratic formula. Okay, so just make sure I'm clear. A is 6, B is 7, C is negative 11. And x is equal to negative 7 plus or minus the square root of 7 squared minus 4 times 6 times negative 11 all over 2 times 6. Okay, let's clean this up. I get negative 7 plus or minus the square root of 49 minus 24 times 11 is 240, and 24 is 264, so it's minus a negative 264 all over 12. And so x is equal to negative 7 plus or minus the square root of 313, because that becomes minus is a plus, all over 12. I don't know if 313 is prime. I won't assume that it is. I certainly don't see any perfect square factors of it. So at this point, I'm going to say I cannot simplify the square root of 313. And my final answer is x is equal to negative 7 plus or minus the square root of 313 all over 12. Okay, one last problem we're going to do in this video. I have x's and x squares all over the place. What do I do to start? Well, we are going to start by overloading one side, getting everything on one side and 0 on another, and then we'll either factor it, complete the square, or use the quadratic formula. So let's move all of this stuff over to the other side so I have a leading coefficient that's positive. You don't need one if you're using the quadratic formula. It doesn't really matter, but it does make things, I don't know. For me, I'm OCD. I don't know what to tell you. All right, so I get 2x squared plus 7x minus 1 is equal to 0. This certainly doesn't factor. 2 and 1, 2 times 1 is 2. There's no way I can come up with something that multiplies to be 2 and adds to be 7. So that's out. I don't want to split the middle term, or sorry, complete the square, because I'm going to have a 7 halves in the middle and then a 49 fourths. I don't want to do that. So we're back to solving by using the quadratic formula. I'm going to take the time to list out A, B, and C, just in the hopes that you actually do also when you get started with this. It's easy to forget that C is a negative 1, or in the previous problem, C is a negative 11. So I like to stay organized when I first start learning things, just so I don't make silly mistakes with signs. Okay, now I'm ready to use the quadratic formula. X is equal to negative 7 plus or minus the square root of 7 squared minus 4 times A times C all over 2A. Let's clean that up. So X is equal to negative 7 plus or minus the square root of 49 minus, let's see, 4 times 2 times negative 1 is negative 8, so minus a minus 8. All over 2 times 2 is 4. So I get X is equal to negative 7 plus or minus the square root of 57 all over 4. 57 is not prime. 57 is 3 times 19, but there's no perfect square factor of 57. So I think I'm done at this point. X is equal to negative 7 plus or minus rad 57 all over 4. Okay, so we saw where the quadratic formula comes from completing the square. We used it in a very straightforward example, and we used it in an example where we had to move things around, but eventually we turned it into a problem that we know how to solve. All right, guys, I'll see you next time.